Hello everybody, this is Jeremy. I am Jeremy. This is Jeremy. Pilot's Handbook of Aeronautical Knowledge. This will be Chapter 4, Aerodynamics of Flight. This will be 4.1, or Introduction. Thrust, drag, lift, and weight are forces that act upon all aircraft in flight. Understanding how these forces work and knowing how to control them with the use of power and flight controls are essential to flight. This chapter discusses the aerodynamics of flight, how design, weight, load factors, and gravity affect an aircraft during flight maneuvers. The four forces acting on an aircraft in straight and level, unaccelerated flight are thrust, drag, lift, and weight. They are defined as follows. Thrust, a forward force produced by the power plant, propeller, or rotor. It opposes or overcomes the force of drag. As a general rule, it acts parallel to the longitudinal axis. However, this is not always the case, as explained later. All right, 4-2. Drag, a rearward retarding force caused by disruption of airflow by the wing, rotor, fuselage, and other protruding objects. Drag opposes thrust and acts rearward parallel to the relative wind. Weight, the combined load of the aircraft itself, the crew, the fuel, the cargo, or baggage. Weight pulls the aircraft downward because of the force of gravity. It opposes lift and acts vertically downward through the aircraft's center of gravity. Lift opposes the downward force of weight. It is produced by the dynamic effect of the air acting on the airfoil and acts perpendicular to the flight path of the center of lift. In steady flight, the sum of these opposing forces is always zero. There can be no unbalanced forces in steady straight flight based on Newton's third law, which states that for every action or force there is an equal but opposite reaction of force. This is true whether flying level or when climbing or descending. It does not mean the four forces are equal. It means the opposing forces are equal too and thereby cancel the effects of each other. In figure 4.1, the force vector of thrust, drag, lift, and weight appear to be equal in value. The usual explanation states, without stipulating that thrust and drag do not equal weight and lift, that thrust equals drag and lift equals weight. Although basically true, this statement can be misleading. It should be understood that in straight level unaccelerated flight, it is true that the opposing lift-weight forces are equal. They are also greater than the opposing forces of thrust-drag that are equal only to each other. Therefore, in steady flight, the sum of all upward forces, not just lift, equals the sum of all downward forces, not just weight. The sum of all forward forces, not just thrust, equals the sum of all backwards forces, not just drag. This refinement of the old thrust equals drag, lift equals weight formula explains that a portion of thrust is directed upward in climbs and acts as if it were lift, while a portion of weight is directed downward or backwards and acts as if it were drag. In glides, a portion of the weight vector is directed forward and therefore acts as thrust. In other words, anytime the flight path of the aircraft is not horizontal, lift, weight, thrust, and drag vectors must each be broken down into two components. Discussions of preceding concepts are frequently omitted in aeronautical text handbooks and manuals. The reason is not that they are inconsequential, but because the main ideas with respect to the aerodynamic forces acting upon an airplane in flight can be presented in their most essential elements without being involved in the technicalities of the aerodynamicists. In point of fact, considering only level flight and normal climbs and glides in a steady state, it is still true that lift provided by the wing or rotor is the primary upward force and weight is the primary downward force. By using the aerodynamic forces of thrust, drag, lift, and weight, pilots can fly a controlled, safe flight. A more detailed discussion of these forces follows. Alright, got a few pictures. Let's see. Alright, we'll end up there. That was a 4-2. 4-2, we're going to start back on 4-2 into thrust. See ya.